Oh, well, hey there. John here again in the Eastman Discovery Lab at the Hands-On Discovery Center, here with another science demonstration for you to try at home. Today we are making your very own lava lamp. You've probably seen them with the glowing globs that rise and fall inside of a glass tube. But also, when you think of the word lava, you might imagine like an active volcano spewing molten rock into the air. We're not doing that kind of lava today, friends, because that lava can be about 2,200 degrees. That's plenty hot enough to burn through the table, burn through the floor, and burn my shoes off, which I'm not excited about today. We also aren't going to be making a real heated lava lamp, because in order to melt that solid block of wax at the bottom of a real lava lamp, it can get over 200 degrees Fahrenheit. Then, once that melted wax gets less dense than the liquid above it, it will rise up, it will lose some of that heat, become more dense than the water or whatever liquid is inside, and fall back down. It's called a convection cell, and that's why the blobs in a lava lamp rise and fall in kind of this circular motion. Today we're going to be using some ingredients that you probably have at home, including cooking oil. Today we have vegetable oil, but you could substitute mineral oil or even baby oil if you want a nice clearer lava lamp. My favorite chemical, dihydrogen monoxide, just water. Add some food coloring for some pizzazz. Of course, you'll need a bottle to make your lava lamp. Our good friend Alka-Seltzer, an effervescent tablet. And for some extra pizzazz, you might want to add some glitter or sequins. You can also add lightweight beads to your lava lamp. And you might want to grab a funnel and a flashlight to really add the wow factor. But let's get started. Our vegetable oil, we're going to fill our bottle. Let's go ahead and plop the funnel in. We're going to fill the bottle about 3/4 full of this vegetable oil. And it takes a second, bear with me. You can cue the background music now. No background music? That's okay. Almost there. And yeah, that's good enough. It's about halfway. And then top it off with our water. And notice something right away, something cool starts happening. The water, as it drops into the oil, will actually start to sink. That is because the water is denser, heavier than the molecules of oil. And as you let it sit for a while, they will actually separate into two very distinct layers. Water and oil do not mix. Water molecules bond pretty well with water molecules. That's how water droplets form. And oil, of course, bonds well with other oil molecules, but they don't bond with each other. So after a couple minutes, this is actually going to separate into two very distinct layers. But we got to press forward. I like blue. Let's add some blue to our lava lamp today. Beautiful. Again, this is water-based, so you can actually see those droplets of food dye dropping to the bottom, where it's actually going to mix in with the water at the bottom. Now, we have to add the pizzazz, folks. So let's add some silver glitter. I like silver, and it's already open, so oops, too much pizzazz. You can never have too much pizzazz. And of course, our favorite friend, Alka-Seltzer, still not a sponsor. It contains sodium bicarbonate and citric acid, a base and an acid. Once it hits the water in the bottom, those chemicals start dissolving and mixing together, and in a chemical reaction produces that carbon dioxide gas, which produces, well, it actually bonds with the water, making it lightweight. Watch what happens. Again, okay, starting to dissolve. Immediately, you start seeing some of these bubbles rising up. That is the lighter, the more buoyant droplets of water mixed with that carbon dioxide rising to the surface. Once those bubbles hit the top, they will actually release the carbon dioxide. Oh, there's glitter in the air. Release the carbon dioxide, making the water more dense, and the water drops back down. I think we might need a little more food coloring in this. There we go. And as the reaction starts to occur, if it slows down, feel free to add more of the Alka-Seltzer. The cool thing about this project is you can actually use this over and over and over again. If the Alka-Seltzer kind of runs out, after it stops bubbling, you can just screw the cap on, put it aside, and you can actually store it for later use. Another cool thing to do, you can put the cap on just very momentarily, because building pressure in there is going to make it really, really pressurized. You can shake it up to make one giant globule of kind of like this viscous goo. That way, when you shine the light through the back or through the side, you can really see all of those sparkles happening. Do you see the sparkles rising and falling? Awesome. Now, this is a groovy project that you can try at home. If you do try this at home, be sure to let us know. Comment down below and maybe send us pictures of your lava lamps if you want. Speaking of which, if you like this video, be sure to hit that thumbs up button. Subscribe to our channel so you never miss a video post. And check the description below. We will be linking a lot of science standards that relate to this project. And as always, keep the science alive, friends. Check the description below, see how you can support our channel, and peace out, Groovy.